This problem is a geometry problem. At the first sight, it may look quite frightening. If we look at this diagram carefully, we can see that we have the length for almost all the line segments except this part. Pretty good. Then we can see that if we look at the right, we have the vertical line here, that's 1. This is 2, that's 1, and this is 6, that's 6. And from the right side, if we just look at the vertical lines, that's basically from the very top to the very bottom. Beautiful. If we look at the left, we have basically the same thing except x. Then that gives us an equation. So we have this 1, 1, 1, this is 2, and this x. Okay, so on the left we have 1 plus 1 plus 1 and plus 2 plus 2 and then plus this x. That equals to the number on the right. That's 1 plus 2, that's this segment. This is 1 plus 1 and then plus 6. Okay, it's quite straightforward to solve this equation. So this gives us 5. This gives us 10. So 5 plus x equals to 10. X equals to 5. So the answer is E. And this problem can be quite interesting. So if we raise all the marks and look at this problem again, we also have an unknown here. We can also solve this. Let's say if this is y, right? We can basically do the same trick. From here to here on the top, we have 4 plus 1 plus 2 and plus 3. That's the length from the very left to the very right. At the same time, on the bottom, we have this 2 and plus this 2 plus the y plus 1 plus 2. Okay, this again is from the very left to the very right. So to solve this, we have, this is that's 5, that's 5, that's 10, equals to, that's 4, 6, 7, 7 plus y. So y equal to 3. So we know this is 3 and this is 5. That's what we originally solved. And we can even make this problem even more interesting. Let's call this A. Let's call this B. What if we want to calculate the distance from A to B? Do you know how to calculate that? That will be a very interesting question, because this looks like a diagonal, but it is not, right? This is not like a rectangle shape or anything like that. But don't worry about it. What if we push this line to this side? And I push this 1, this 2, all the way down to here. And I push this 1 all the way to here. So you see, we formed a right triangle. Then by Pythagorean theorem, we can calculate this, right? We know this is 3, and we know that this is 1, this is 2, This is 6, this is 1. So the distance from A to C, that will be 3. Let's put it this way. From A to C, the distance is 3 plus 1 plus 2 equal to 6. And the distance from B to C, that is 2 plus 1 plus 6, that's 9. 2 plus 1 plus 6, that's 9. Then, the distance of AB will equal to the square root of AC squared plus BC squared, equal to 36 plus 81, equal to square root of 117. So the trick here is, if we push all the lines out, we can know that this is actually a square. So we can calculate the length of all segments, like AB, or like this big diagonal, or anything, like from here to here. If you like this video, please subscribe and thumb up. If you have questions, please comment.